Okay, and today as we move on, we're going to be looking at another sampling technique. We're still looking at random sampling techniques, and today we're going to look at stratified sampling. Stratified sampling, what is it? Have you seen it before? What are its pros and cons? And how exactly do we conduct a stratified sample? Now, if the population can sensibly be divided into useful subgroupings or categories, which we actually call strata, such as maybe gender or age, then stratified sampling can be used.
So I was expecting for this to be one of the most familiar ones to you, because stratified sampling comes up quite a bit in GCSE, and there they focus on, do you really understand that we're trying to look for a proportion of each of the categories to be represented in the sample?
Stratified sampling ensures that all strata, all of the categories are going to be represented and involved within the sample that we choose. Not only do we want to make sure that they're represented, but we want to make sure that there's some proportionality to the way they're represented. If 50% of the population is one category, we want 50% of the sample to be that category as well. Okay, so here I've got a population of cars. We've got different colours, and you can see that there's more black cars than any of the others. Let's see how we'll take a stratified sample in this case.
So we'll start off by making sure that we add unique numbers to each of the sampling units within each of the categories. So the black cars will go from 1 to 20, the red from 1 to 5, the purple from 1 to 3, and the blue from 1 to 12.
So we're going to need to calculate how many of each of these colours is going to be needed. And we're going to use a formula to get there. And the formula says the number of each strata needed is going to be the sample size times the strata size divided by the population size. I'm going to go ahead with a sample of 10 again, just like I did last time. So in the first case, it's going to be 10 times 20 divided by 40. Meaning I'm going to need 5 black cars to be part of the sample. And this makes sense. Half of the population were black cars, so half of the sample should be black cars as well. Okay, let's carry on for some of the other categories. Let's look at the red cars. Once again, to find the number that I need, it should be the sample size of 10 multiplied by the strata size of 5, there were 5 red cars, divided by 40, which gives me 1.25, but I do need an integer value, so I'll round that to 1. I will have 1 red car represented in the sample. Okay, what about these purple cars? So the strata size is 3, so we should have 10 times 3 over 40, 0.75, and I can round that once again to 1. I'll have 1 purple car in the sample. And lastly, we have these blue cars. We're going to do 10 multiplied by 12 divided by 40 gives us 3. There should be 3 blue cars in the sample. So this is what my sample should look like. 5 black cars, 1 red, 1 purple, 3 blue. Now we've rounded some of our values, so obviously just a quick check to make sure that I do have a sample size of 10, and these will add up to 10. So exactly what I was looking for. Now, to pick the 5 black cars, I need to do a simple random sample within those black cars only. So just like we saw in the previous video, I'm going to set my random number generator from 1 to 20, and I'm going to go ahead and try and pick 5 unique numbers that represent those black cars. So we start off with 3. This is part of the sample. 17 will be part of the sample. 16 and 5. These are both part of the sample as well. And the last one is 3. Well, hold on, we've got a duplicate again, and we know we have to ignore the 3, and we're going to choose one more number, 15. So I have the 5 values that would represent the black cars that are part of the sample. Let's go ahead and do a similar thing for the red cars. There's only 5 to pick from, so I'm going to set my conditions from the minimum of 1, maximum of 5, pick a number at random, it's number 4. Red car number 4 is part of the sample. The same for purple. I'm going to set my limits from 1 to 3, pick a number at random, purple car number 2 is part of the sample. And lastly, for the blue cars, I'll set the limits from 1 to 12 and pick 3 random numbers, and those 3 will be part of the sample. So I've picked 2, I've picked 3, and we've got another duplicate. 3 can't be included twice, so I'm just going to pick one more number, and this time round we get 5. So 2, 3, and 5 are the blue cars that will be part of the sample. Once again, if you're asked in the exam to describe how to take a stratified sample, you'll need to mention each of these steps, and specifically that you're going to take a simple random sample within each strata, a simple random sample within each category. And as last time, don't forget to explain what happens when you get a duplicate value. Just a point for you to be aware of, if we actually had a large population and one of the strata was quite small, when we do this calculation, we might get a value that rounds down to 0. We don't really want this to happen, because then that particular strata, that particular category, won't be represented in the sample. So to avoid this, we just make sure that the minimum value of each strata is going to be 1, just to enforce representation, and then we might reduce one of the larger categories to make sure that we actually add up to the sample size we needed in the first place. So don't expect it to happen very often, but I do need you to be aware that we won't make any of the categories equal to 0. Okay, and just before we go into an example, let's just reiterate some of the advantages and disadvantages of taking a stratified sample. So hopefully this is something you recall from GCSE. The advantages of a stratified sample is that it actually reflects the population structure. It guarantees proportional representation of the groups within the population. We, in our sample, have similar proportions, approximate proportions to how each of these categories and strata exist in the population. So we can be confident that we have a representative sample. Disadvantages: the population has to be clearly classified into distinct strata. Sometimes it might be hard to decide whether people belong to one group or another, and if there's overlap and it's not easy to determine exactly which strata they belong to, then stratified sampling might be a little more difficult to put in place.
If we were thinking of the genre of movies that we were investigating, it might actually become difficult to place a particular movie into a particular genre, for the mere fact that some movies are 2 genres at once. It might be a comedy fantasy movie, it might be a comedy sci-fi movie, it might be a sci-fi thriller. And because of that overlap, individual movies, individual sampling units may not actually be placed into the correct category. So if it is difficult or ambiguous to categorize these,
that wouldn't be a sensible way for me to try and put them into distinct strata. And an additional disadvantage comes from the fact that within each strata we try to perform a simple random sample. So all of the disadvantages that come with a simple random sample will be present when we get to that stage of stratified sampling. So once again, we're going to need a sampling frame for us to be able to make our selections from, for us to be able to number, for us to be able to pick random numbers from, for us to be able to make our selection from. And this is actually difficult when we have a large population. So a very large population makes it difficult for stratified sampling to be processed. Okay, so let's jump into an example. In this one that I've got on the screen, we're told that a factory manager wants to find out what his workers think about the factory's canteen facilities, about the food that they provide to their workers. The manager decides to give a questionnaire to a sample of 80 workers. So he's chosen a sample size of 80. It's thought that different age groups of workers will have different opinions. Alright, and then we're told how many workers belong to each of the age groups. So 18 to 32, I'll call those junior employees. There are 75 of them. Aged 33 to 47, experienced employees, there's 140 of them. And aged 48 to 62, we'll call those the senior employees, there's 85 of them. So in total, there are 300 employees. Okay, we're asked to write down the name of the method of sampling the manager should use. Well, since he thinks that each of these different workers will have different opinions, he wants each of them to be represented, and they're already split into really good strata, or they're already split into really distinct strata. This screams stratified sampling. It's stratified sampling that he should use. Part B asks us to explain how the manager should use stratified sampling to select a sample of the workers' opinions. Okay, so let's just get down to performing a stratified sample. So to start off with, I'm just going to perform some calculations to decide how many members of each strata I'm going to need within my sample. So for each of them, I'm going to take the strata size, multiply it by the desired sample size, and divide by the total population size. So for the junior employees, 75 times 80 over 300 says that I need 20 junior employees. For the experienced employees, 140 times 80 over 300. So that gives us 37.3, but I know I'm going to need an integer value, so I'll approximate that to 37 experienced employees. And then lastly, there's 85 senior employees, 85 times 80 over 300, 22.67, which once again we can approximate to 23 senior employees. Alright, at this point I always just do a check. Do these numbers add up to the desired sample size? 20, 37, 23. Altogether that gives me 80. So that's spot on. I'm happy to carry on with this stratified sample. Okay, so in each of the cases, we're going to specify exactly what we need to do to produce a stratified sample. So for the junior employees, I need to number the junior employees from 1 to 75. And then I need to pick 20 unique numbers using a calculator or random number generator, and all of the employees who correspond to those unique numbers will form part of the sample. For the experienced employees, I need to number them from 1 to 140 and pick 37 unique numbers from them. The employees who correspond with those 37 unique numbers will also be part of the sample. And lastly, for the senior employees, I'm going to number each of them from 1 to 85. Go ahead and pick 23 unique numbers, and all of the senior employees who correspond to those 23 unique numbers are going to be part of the sample. So I have a sample of 80, which is made up from 20 junior employees, 37 experienced employees, and 23 senior employees. If you notice, I always use the word unique. So technically I don't need to describe what happens with duplicates, but it doesn't do any harm to add in that any duplicate numbers that are selected, we will just go ahead and ignore those. Alright, and this is the response that we would need to pick up our marks. Okay, and we're just about finished, but before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show. Exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A star.